To help answer some true or false questions about this function, it might first help to graph it. Now, as a reminder, x to the 2/3 is a graph that looks like the way you drew a bird in kindergarten, like this. So what do this 3 and this minus do to that graph? It's going to shift it up by 3 units, and then it's going to reflect it over the x-axis. So let me show you what that looks like. We're now going to look at a graph that's been shifted up 3 units, and now it kind of looks like this. Now we've got a graph going on here. Can we answer these questions? Well, sure. Is there a local maximum at x equals 0? Yeah, it seems to be there's a peak here. The mountaintop is reached, and so there is indeed a local max at x equals 0. So this is true. Concave down on negative infinity to 0 and 0 to infinity. Well, that way we're going to, in order to determine concavity, we're going to put 2 dots above the curve. And when you put 2 dots above the graph to help determine concavity, you're looking either for a smile or a frown. Now these 2 dots, I kind of see a smile here and a smile here. And because I see a smile, that means the graph is concave up. And you can put different lines or different dots wherever you want, but if you keep seeing a smile, that means it's concave up. If you see a frown, that means it's concave down. Nice little rhyme to it. So it's not concave down, it's actually concave up because we see a smile. Okay, and this says the derivative exists for all x. Now that's not quite true because this function and this function, their derivative does not exist at x equals 0. That sharp turn or that cusp is a point where the graph is not differentiable. So the derivative exists everywhere except x equals 0. So the first guy is true, these last two are false.